So this is half of the last trig identity that I'm going to give you guys. The rest of them come out of these. So don't sweat it. We're almost done with identities. I need to give you the double angle identity for cosine. I claim you already know most of this thing. Okay? So what I'm looking for is I'm looking for cosine of 2 theta is some stuff. Right? If you double an angle, you should be able to figure something out about the cosine. How can I think about this in terms of something I already know with you? If you double an angle, what's that the same thing as? Adding it to itself, right? So cosine of 2 theta is the same thing as cosine of theta plus theta. Yeah? Okay, so now I can apply the what? The sum of angles identity that I already have from the other day. So what's the sum of angles identity for cosine say?
Cosine of the first thing, cosine of the second thing.
Cosine of the first thing, cosine of the second thing, minus sine of the first thing, sine of the second thing. Yes? What are all the things? Yeah, all the things in here are theta, right? You guys all see that? So this is what? Cosine squared of theta. Okay, see that? I'm multiplying these. Minus sine squared of theta. Okay, please careful. Why am I telling you to please careful right now? Yeah, this looks a little bit like the Pythagorean theorem thing, right? So you might be a little inclined to say what?
Well, because
Equals 1, but it's not, because there's a minus sign here, right? So careful. That's the careful. This looks a little bit like something that's not quite the same.
Does it equal anything?
Ah, does it equal anything? Yes. So, you guys see this sine squared piece over here? Okay, so it would be a lot more convenient for me if I could only have one trig function over here, yeah? You guys see that? Okay, so I'm going to force it so there's only one trig function over here. So let me see. I'm looking at sine squared of theta, and I'm looking to have rid of this thing. Okay, so what do I know about sine squared of theta? Squared. I know that if I add it to cosine squared of theta, I'll get 1, right? Okay, so take this thing and subtract. I think I want to move the cosines to the other side. Okay, so if I subtract cosine squared theta from both sides, I'll have sine squared of theta is 1 minus cosine squared of theta. You guys see that? Then what am I going to do with the blue information? I'm going to take that, I'm going to plug it in here. And I'm going to figure out that the double angle identity is cosine squared theta minus all of 1 minus cosine squared theta. And what do you get? Okay, so make sure you distribute your minus sign, right? So 2 cosine squared of theta minus 1. And this is supposed to be cosine of 2 theta. Cool? Right.
And we're seeing stuff. But
yeah, so what is this thing good for? Yeah, this one's actually good for something in calculus class. This is good for dropping the powers on cosines. You guys see that? Here I've got a cosine squared of some angle, and I can trade that for a cosine with one lower exponent, right? And some other jazz with a different angle.
Isn't that just
You guys see that?
Isn't that cosine 2 theta every time that's the same?
This thing? So yeah, this is the same thing I started with. I just wrote it down at the end. This thing is this thing, is the punchline.
I thought that was the answer that you got. The one on the left is the answer.
Yeah. Well, the answer is this whole box,
Well,
really.
yeah, that equals.
You guys okay with this? So this is a trick that lets you trade powers off of cosines for doubling the angles. It turns out there's a good reason you would want to do that later. Cool. I believe that you all are scared enough of exponents to want to do this. Is that true? Maybe not? Okay, we'll get there.